Hi, I'm Mr. Levier, and I'm here at the Johnson's Geo Center in St. John's, Newfoundland. We are here to meet Rod Taylor, and he is a paleontologist here, and he's going to tell us about some of the very first animals that lived on planet Earth.
My name is Rod Taylor, and I'm one of the interpreters here at the Johnson Geo Center. I'm also a part of the Memorial University Paleontology Research Group, so I've got my hands in two pots. Day to day, this is where I spend my time. We work here at the Science Center as a public education facility, discussing the geology of Newfoundland as well as the recent ecological history, looking at things like glaciation and such. But again, we do a lot of different material because Newfoundland has a very complicated geological history. It's one of the truly unique places in the world to see geology. The east coast of the island is actually Precambrian in origin, about 550 to 575 million years old by and large, formed off the north coast of Africa when it was originally part of a massive continent called Gondwana that covered the South Pole. The west coast of the island is actually a part of the North American landmass, a part of the Canadian Shield, an ancient volcanic rock sequence that's probably anywhere from 1.5 to 2.5 billion years old, depending on where you are. And the center of the island is actually an ocean floor that existed between those two separate land masses. So when this small part of Africa broke away about 500 million years ago and moved north, when it struck North America about 400 million years ago, the Iapetus Ocean, which is the seafloor between them, the seafloor was compressed and lifted to fill the gap in between. So Newfoundland's geology is partly volcanic rock from North America, partly sedimentary rock from Africa, and partly the ocean floor that existed between them. So, not surprisingly, the geology here in Newfoundland is very complicated, but it also gives us some really good stories because there are things here that you see exposed that we don't find anywhere else. On the east coast of the island, here on the Avalon Peninsula and directly north of us on the Burin Peninsula, we have several sites with Ediacaran fossils. Those range in age from about 575 to about 550 million years old, and they actually represent the oldest known complex animals on the planet. And when we say complex, we don't necessarily mean complex in the modern sense, complex in the sense that they actually start to show differentiation of tissues into different types. So we've got a bottom layer, a top layer, and a middle layer, and that's basically enough to define something as an animal when it comes to tissue development. So yes, we have Mistaken Point and we have the Discovery Trail. Those are two UNESCO World Heritage Sites because of the paleontology, which is it's unique in its numbers and its preservation here. There are related forms preserved in parts of Europe. For example, in Chartwood Forest in England, we find some fossils that are similar in age. But the scale and the number of specimens and the preservation is much better here in Newfoundland, to be perfectly honest. So we're very lucky. A lot of people actually come to Newfoundland every year to study the fossils here and to work on the material that we have. And as we say, it's incredibly well preserved. The numbers, we're looking at things in the tens of thousands, and I've actually got a few specimens here. This is an example of a cast of a specimen called Fractifusus. This is an organism from Mistaken Point. We don't actually have an actual specimen because they're illegal to collect. These organisms, these fossils are so rare, the government has policies in place to protect them. So they're illegal to actually take or remove, even for science centers like ourselves. So it looks a little bit like a leaf or a frond, but this is actually an organism that lived on the deep sea floor. Estimates are that it was more than 2 kilometers deep. So even though it looks a bit like a leaf, it never would have seen sunlight. So we know that they were animals. And they show an unusual kind of development. They belong to a group called the rangeomorphs, and they were characterized by what we call fractal branching. So it's an organism made up of 2 sets of branches on either side. Each side has multiple branches. You can almost see here they're almost like fingers running in parallel. And each of these branches is made up of smaller subunits. Those branches are made up of smaller subunits again. So these organisms basically had a really, really high surface area, which would have enabled them to interact with the environment around them much more effectively than if they just had a very smooth surface area. So they probably exchanged wastes with the environment by passing it through the tissue, skin. They probably would have absorbed nutrients at the same time, like oxygen, maybe even food. We also think they may have had chemosymbionts, so bacteria that lived either on the lower surface or in the lower surface that they would have actually exchanged nutrients with, and they would have actually helped to keep toxins from developing in the area around them. Because living on the deep sea floor, being relatively large, with very low water currents traveling around them at the time, it would have been very easy for carbon dioxide to build up underneath them and for sulfides to build up underneath as well, which can be toxic. So chemosymbiotic bacteria would have actually helped to regulate the environment to make it a lot more protected for them. So this is a nice little cast of one of the specimens. What I've got here is also, this is actually a 3D print of the same organism, and this is based on a paper that we had published about 2 years ago where we described the morphology of this organism. And we identified that the top and the lower surface, this is the bottom surface and this is the top surface, would actually have been different. Whereas traditionally the take was that it was actually the upper and the lower surfaces were probably the same. But after a couple of years of research studying several hundred specimens, we basically realized just how much more complicated these organisms are than anyone ever really appreciated before. So this is just a nice little tool that we can use to demonstrate to people how these multiple branches are made up of smaller elements and such, and how the top and the bottom surfaces were probably quite different. In these organisms, they lived by the thousands. At the Mistaken Point site proper, when you go on tours down there, because there's an interpretation center at Mistaken Point where you can actually go on a guided tour to the site. But these animals didn't survive into the Cambrian. There's one genus that survived into the lower Cambrian, basically, Charnia, but they disappeared very quickly once you got into the Cambrian. So even though these animals dominated the oceans at one point, they only dominated for a few million years, and then they were basically outcompeted by other things that evolved that could move around, that had muscles, that had predatory mouth parts, etc. So they didn't survive very long. One of the interesting things with the organisms from the Ediacaran here in Newfoundland, as we say, most of these, like Fractifusus and the other rangeomorphs, they didn't have muscles, they couldn't move. These were animals that lived on the seafloor in position and stayed where they were. But in recent years, we've actually discovered a couple of other species, not here at Mistaken Point, but slightly to the north in the Port Union area at the Discovery Trail on the Bonavista Peninsula. And these organisms actually have muscular tissue, and based on the science that we've done with them, we've identified two separate species, one of them called Hautia quadriformis, the second one called Mamsetia minunis, and they actually are early relatives of a group of modern animals that are called the storozoans, also known commonly as the stalk jellyfish. So if you imagine a jellyfish, they swim sort of doing this upside down cup thing. If you take one and turn it upside down and give it a stalk, and turn those little tendrils into muscular tentacles, that's basically what you get. And in the oceans around the world today, they are extremely common. Here in the North Atlantic off the coast of Newfoundland on the east coast, you can find them in the millions just by going a few meters deep into the ocean floor, into the ocean. And these fossils are interesting because they're the oldest known animals anywhere on the planet that have muscular tissue. But not only that, their morphology, their shape, their design, the muscles that we see, the organs. We can't see the organs, but we can see the body designs. They are extremely similar. We are almost certain that this is a precursor to the modern forms. And it's very rare to be able to look at a fossil and say it is either a direct descendant or very, very close to the direct descendant. So at the time when these organisms were alive, our non-muscular organisms that belong on the seafloor, we actually find evidence of the beginning of muscular animals that were actually able to move around, were predatory, and would probably have treated these organisms as a wonderful little food source. So it was a bit like finding a salad buffet that you could help yourself to however much you wanted. I would highly recommend anybody interested in either geological outcrops that are unusual or early paleontology to come visit Newfoundland, because we've got some spectacular outcrops around the entire island. Much of our coastline is rugged, physically transformed, beautiful sequences. Not surprisingly, because of the geological history we have, we essentially were brought together during a mountain building episode, so we see some incredibly unusual rock formations. We've got some incredibly rich paleontology. As I say, we've got Mistaken Point, and we've got the Port Union area with the Precambrian fossils. On the southern part of the island, we have Fortune Head, which is on the Burin Peninsula, which has the world stratotype sequence for the Precambrian-Cambrian boundary. In western Newfoundland, at Green Point in Gros Morne, we have the world stratotype section for the Cambrian-Ordovician boundary. So we've got some incredibly important geological sequences there that are also spectacular in terms of the view and the scenery that you see there. Bell Island, which is very close to St. John's, has some fantastically well-preserved Ordovician trilobite trace fossils and worm burrows and such. The amount of material here is truly incredible. There's Cambrian trilobites at Manuel's River if you wanted to go explore there. It's another protected site because it's such a valuable fossil and geological resource. So I honestly, even though I was born and bred here, I can honestly say that I have not seen many places that have as much unusual and interesting geology concentrated in a small an area as you'll find here in Newfoundland. So it's wonderful. We get geotourists through here every year, and the more people we get through here, they all say they loved it, they want to come back, they're going to come back again. I can't recommend it highly enough.